In last lecture, we have discussed about we just started the vector calculus. वेक्टर कैलकुलस हमने स्टार्ट किया था, उसके अंदर जनरली वी डिफाइंड द वेक्टर फंक्शन, जैसे हमारा रियल फंक्शन होता था, यानी सिंपल स्केलर फंक्शन होता था, उसी तरह से हमने वेक्टर फंक्शन डिफाइन किया था विद रिस्पेक्ट टू दी स्केलर पॉइंट. देन वी डिफाइन द डेरिवेटिव ऑफ दैट वेक्टर फंक्शन, उसका डेरिवेटिव हमने डिफाइन किया था. और उसके बाद हमने कुछ जनरल रूल्स फॉर द डिफरेंशिएशन इन द वेक्टर फंक्शन में, वही जनरल रूल थे हमारे जो सिंपल स्केलर फंक्शन में होते थे, वही जनरल रूल हमने डिस्कस किए थे. और देन फाइनली डेरिवेटिव ऑफ ए कांस्टेंट फंक्शन, डेरिवेटिव ऑफ ए कांस्टेंट फंक्शन का क्या होता था वो डिस्कस किया था. और डेरिवेटिव ऑफ ए वेक्टर फंक्शन इन टर्म्स ऑफ इट्स कंपोनेंट फॉर्म, उसकी कंपोनेंट फॉर्म में वेक्टर फंक्शन का डेरिवेटिव क्या होगा. और लास्ट दो हमारे टॉपिक थे क्या, कि अगर f of t has a constant magnitude, then f dot df upon dt, that means f and df upon dt are perpendicular. और लास्ट में f of t has a constant direction, then f cross df upon dt is a zero vector. f cross df upon dt is a जीरो वेक्टर. ये आई थिंक मुझे ध्यान आ रहा है कि पैरेलल की कंडीशन भी होती थी कि दो वेक्टर अगर पैरेलल हैं तो उनकी क्रॉस प्रोडक्ट जीरो होती है. तो यानी अगर उनका मैग्नीट्यूड, उसका डायरेक्शन कांस्टेंट होगी, तो इट मींस एफ और डी एफ अपॉन डी टी बोथ आर इन द सेम डायरेक्शन. दिस वी हैव प्रूव्ड. ठीक है. द नेक्स्ट टॉपिक है हमारे पास में, दैट इज ज्योमेट्रिकल इंटरप्रिटेशन ऑफ द डी आर अपॉन डी टी. Geometrical interpretation of dr upon dt, where r is the position vector of a point, or you can say the physical interpretation of the dr upon dt. For that part, let O be the origin of reference, O be the origin, let the position vector of a point P be given by vector r is equal to be f of t as t varies continuously, and P is just a moving point, as t varies continuously, P traces out a curve like this curve. This consider as a C. Let it be consider this point as a P, and this will be the position vector P of P. This direction we consider as a y-axis, x-axis, and z-axis. C. Thus, a vector function f of t, represents the curve in the space. Represents a curve in a space. For example, let us consider example 1. Let the vector equation r is equal to be at square I 2atj represents, it is in two dimension, represents the parabola. Y square is equal to be 4ax in the xy plane. Because its parametric equation is as its parametric equation are x is equal to be 80 square and y is equal to be 280. You can simplify, you will get this parabola y square is equal to be 4ax. Similarly, one more example is to be considered for like this, the vector equation. Let the vector equation r is equal to be a cos t I plus b sin t j represents the ellipse x square upon a square plus y square upon b square is equal to be 1 in the xy plane. In the xy plane, as its parametric equation is parametric r x is equal to be a cos t and y is equal to be b sin t. This we bifurcate into the general Cartesian form to the parametric form. Now come to the part that is the geometrical interpretation of dr upon dt. Now let r is equal to be f of t be the position vector, in two neighborhood points. Sorry, r will be a vector equation, not a position vector, or vector equation of the car. First we consider the vector equation, then we consider the two position vector of the two different points. पहले हम r को एक तरह से कार पे मानेंगे, be the vector equation of the car, be the vector equation of the car. C in the space, let r and r plus delta r be the position vectors of two neighborhood points, neighboring points P and Q on this car. Let us consider we have the car. This is the car C. We consider one point as a P and another point as a Q. This is the origin. This is the position vector with respect to the origin R. This is the position vector with respect to the origin R plus delta R. We would like to draw the tangent line at this car. Draw the tangent line first at the point P to the car. We consider R and R plus 1. Then we find the vector PQ using the position vector point or triangle law of addition. Using the triangle law of addition, that is PQ vector PQ. This is the vector PQ. As per the triangle law of addition, this is equal to be OQ vector minus OP vector. What is OQ vector? OQ vector is R plus delta R, and OP vector is R vector. Then it is equal to be delta R. Therefore, this is a change. Then similarly, you will find the delta R upon delta T is directed along the chord PQ. Along the chord, this is the chord PQ. This chord PQ. Delta R upon delta T is directed along the chord PQ. As delta T tends to 0, that means that is Q approaches to be P. Q approaches to be P. The chord PQ approaches to what? That is tangent to the curve. Tangent to the curve at point P. So what does it mean? It means the limit delta T tends to 0, then delta R upon delta T will become dr upon dt. Dr upon dt is a vector along the tangent to the curve. Tangent to the curve at P. Tangent to the curve at P. This is the physical significance, or you can say what does this dr upon dt give us. यानी जो dr upon dt है वो हमें क्या देगा, वो that is called the vector along the tangent to the curve. Vector along the tangent to the curve. And suppose the scalar parameter t is replaced by S, where S denotes the arc length from any convenient point, point, say it is A, on the curve up to P. Thus, what does we have? Thus, length of the arc AP will be S, and the length of arc AQ will be S plus delta S, so that delta S will become the arc PQ. In this case, what will happen? In this case, the dr upon ds, instead of dr upon dt, it will become dr upon ds, will be a vector along the tangent at P, and simultaneously also this dr upon dt, dr upon ds magnitude will become limit delta S tends to 0 of delta R upon delta S. That means the limit delta S approaches to 0. What does it mean? It means Q approaches to be P. The delta R is, that is chord PQ, and delta S is, that is arc PQ. Both are equivalent, then it will become 1. Therefore, what we have, what we concluded? We concluded that dr upon ds is the unit vector, is the unit vector, say represented as a t cap, along the tangent, along the tangent at P. This dr upon ds represents the unit vector along the tangent because its direction is along the tangent at P. So it is a unit vector in that direction. This is the complete physical significance of dr upon dt when this, instead of t, we replace s, where s stands for the arc of the some length of some arc, then it represents the unit vector along the tangent P. Then come to the part, the next first derivative, that is dr upon dt is defined. Then for further derivative of this dr upon dt, we should take up the two quantities, two physical quantities. One is velocity and another one is acceleration. If the scalar variable t denotes the time and vector r is the position vector of a moving point, of a moving point or moving particle P, then delta r is the displacement, of the particle in time delta t, and the vector delta r upon delta t is the average velocity of the particle, is the average velocity of the particle during the interval delta t. And delta r upon delta t represents the average velocity of the particle during the interval delta t. If v represents the velocity, v stands for the velocity, v represents the velocity vector, of the particle at P, then v will become, the vector v will become the limit delta t tends to 0 on this vector delta r upon delta t, that will become dr upon dt. That means dr upon dt is the velocity vector, and its direction we have already discussed about the direction of this dr upon dt. That is, direction is along the tangent at P. And if that delta r represents the displacement, then this dr upon dt will be the velocity vector for that particle. And further, for the acceleration, if delta v be the change in the velocity v during the time delta t. Then this delta v upon delta t is the average acceleration, is the average acceleration of the particle during the interval delta t. And if a, as we discussed earlier, that is v is the velocity vector, here we consider the a denotes the represents the acceleration of the particle, how acceleration vector of the particle at p, of the particle at p. Then this acceleration a will become limit delta t tends to 0, delta v upon delta t, which will become dv upon dt. That means the second order derivative of this dr upon dt, d square r upon dt square. This will be the acceleration of the particle at point P. These two we have defined. One is the velocity vector, another is the acceleration vector. Velocity vector is the, that is, if delta r will be the displacement, then velocity vector is a dr upon dt, and the acceleration will becomes the dv upon dt. That means the successive second order derivative of the displacement, that is d square r upon dt square. Now let us consider the example on the basis of these two defined and some derivatives. Prove that if vector r is equal to be a vector a sine omega t plus vector b cos omega t, where a, b, omega are constants, whereas vector a and b are vectors and omega is a scalar, then what is to prove? We have to prove d square r upon dt square is equal to be minus omega square r vector, and vector r cross product with the dr upon dt will become minus omega times of a cross b. This is to prove. This two thing is to prove wherever we have given the vector r is equal to be vector a into sine of omega t plus vector b into cos omega t. Then these two things are to be proved. Just simplify. Let us consider the solution. Since we know that if r is equal to be 5 times of vector af, where phi is a scalar, function of t, then as per the general rule we have already defined, dr upon dt will become 5 times of df upon dt plus d phi upon dt into vector f. But if we consider the f is a constant vector, but if f is a constant vector, then df upon dt will become 0 vector. These are to be considered because we have a given vector a and vector b are constant vectors. A और B हमारे पास में वेक्टर दे रखे हैं, वो कांस्टेंट वेक्टर दे रखे हैं. So for considering the derivative of those, they becomes 0. So it means this implies dr upon dt will become d phi upon dt into vector f. ये आपका बन जाएगा in this case. Now we consider about r जिसका हमने डेरिवेटिव लेना है. Let us consider r is equal to be a vector a, r is equal to be vector a into sine omega t. Sine omega t like as a phi and a vector a. Similarly vector b and cos omega t like as a phi. This implies dr upon dt will become vector a because of the constant, as in the case of above we have discussed. जो भी चीज हमने इसमें डिस्कस की है that will be applied because a vector आपके पास में constant है, तो a represents as a f vector, similarly b represents as a f vector. The phi represents as a sin omega t, and some in this part it represents as a cos omega t. So we consider like that part, that will become vector a into derivative of this sin omega t, that will become cos omega t into omega, that is omega into cos omega t. And similarly derivative of the second, that is cos omega t, that is minus sin omega t into omega, that is minus b vector omega sin omega t. This is a derivative dr upon dt. Again consider the second order derivative, because in the one case we require the second order derivative, in the second case we require the cross product of r with the dr upon dt. d square r upon dt square. Again, because a is a constant, a omega is a constant, only the derivative of cos omega t, that will become minus times of sin omega t into omega, that is minus omega square minus a factor omega square sin omega t. And sin omega t is again cos omega t into omega, that is minus b vector omega square cos omega t, that is equal to be minus omega square considered as a common, remaining will be vector a sin omega t plus b cos omega t, which we have given as a vector r using 1. So using 1, this implies, which is equal to be minus omega square vector r using 1. Hence the first part. Hence the first part is to be proved. The first part हमने prove करना था. This is the first part to be proved. Now come to the second part, that is cross product of the also r dr upon dt. That means r is vector a sin omega t plus vector b cos omega t. And what about the vector r? Vector r dr upon dt is, we have already considered this, the dr upon dt from the equation number 2. From the equation number 2, that is vector a into omega cos omega t, vector a cos omega t minus vector b omega into sin omega t. We consider the cross product of these two. Wherever the cross product between the vectors, the scalar quantity will comes out. Apply the distributive law. Apply the distributive law. You can this cross with this cross. Then this part will be the constant part, scalar part. This part is also scalar part. This comes out. Only we have the a cross a, that will become 0. A vector, a cross product of a vector with itself always becomes 0. So first part will become 0. Come to the second part, that is a cross with this part, that is again omega sin omega t, and sin omega t is a constant scalar quantity that comes out. This cross product between the a and b. This is the part. Similarly, come to this first part, that is minus omega, it is sin square omega square, it is sin square omega t, and remaining cross product between only a and b. Cross product between only and a and b. This is the first part. Now come to the second part. In the second part, what will happen? B cross with this A will become omega and cos square omega t, omega into cos square omega t into B cross A. And for the second part, that is B, because we have the cross product between B and B, that will become 0. In second part में हमारे पास में the vector cross product with the vector itself, that will become 0. So that will diminish. So only the first term will be left behind. That means plus. Again we have the omega cos square omega t into B cross A. We mention here because A cross A is equal to B 0 vector also is equal to B cross B. These two vectors are 0 vector. So we consider in the above part omega as a common, and in the second part, as we know that the A cross B is equal to B minus times of B cross A, or you can say the B cross A is minus times of A cross B. B cross A is equal to B minus times of A cross B. We consider this part in the second term. In this term, we have the B cross A that will replace with the minus times of A cross B. So again, we have the A cross, this will become A cross B, this will become A cross B. So minus times of A cross B is also considered as a common. Minus times of A cross B is also considered as a common. Minus omega A cross B considered as a common. Remaining will be sine square omega t plus cos square omega t, which is equal to be 1. Because for every theta, sine square theta plus cos square theta is equal to be 1. We here again try to understand this B cross A. We have this B cross A. B cross A will replace with minus times of A cross B. That minus and this minus comes as a common. Again, A cross B and A cross B consider as a common. And remaining term will be sine square omega t and cos square omega t. That will become 1. Hence, what we get? We get vector r cross dr upon dt will become minus omega into A cross B, which is required to be proved in the second part. Hence the result. Similarly, one can prove the other parts also. Let us consider one more example, which is of the different type. If vector r is a vector function, of a scalar t, and vector A is a constant vector, then differentiate the following. With respect to the scalar point t. What are the following? First part will become the whose differentiation is to be considered. The vector r cross product with vector A divided by vector r dot with vector A, and second part whose differentiate is to be evaluated, that is vector r plus vector A divided by r square plus A square. These two are to be determined. Now let us consider the solution. The differentiation of these two parts is to be determined. First part, let us consider this whole represent a single vector because it is a vector quantity. In denominator, we have the scalar quantity, that is dot product of two vectors is a scalar quantity and cross product of two vectors is a vector quantity. So this whole will become a vector quantity. In right hand side also, it will become the vector quantity. In the second part also, it will become the vector quantity. Let us consider this as a single vector on which differentiation is to be considered. Let this is a vector P is equal to be vector R cross A divided by vector R dot with A. Then here dot product of two vector is always a scalar quantity, though R dot A is a scalar function, which is like as a phi scalar function of T, and as vector A is a constant vector, so dA upon dt is a zero vector. These are to be remembered. Then consider this dp upon dt. Therefore, consider the differentiation of this whole vector, that is dp upon dt will become, is R dot A will just behave as a phi. Phi is a scalar quantity. That is phi multiple with the derivative of the vector quantity, that is R cross A plus derivative of this scalar quantity, that is phi 1 upon R dot A into this vector quantity. Try to be very careful in this one. What we have, we have R dot product with A, and for the second part, that is ddt of this dr cross t, apply the general rule, R h t cross of derivative of d upon dt plus dr upon dt cross product with vector R. And in the second part, we consider the derivative of 1 upon R h t. Simply just consider the derivative of 1 upon, just like a 1 upon x. Derivative of 1 upon x is minus 1 upon x square into that part. In the same way here, we consider the derivative of this part and this as it is, that is minus times of, in denominator we have the derivative of that part, derivative of this R dot A whole square into R cross A. We consider the derivative like this one, that is derivative of 1 upon f of t, that is minus times of f dash t divided by f of t whole square. We like the derivative of this one. Then simplify, just to simplify, that is equal to be this 1 upon R dot A is as t, so only the derivative. This part will become 0 because d upon dt will be 0. d upon dt will be 0 as A is the constant vector. So only left behind we have this term into with this one. That means you can consider like this one, that is R dot dr upon dt cross product with A divided by R dot A. This is the first term. And in second term, what we have? We have in denominator, we have the square of this R dot A. In numerator, we have the derivative of this. Apply the general rule, the derivative in product rule dot product, that is R dot dA upon dt plus dr upon dt dot with A divided by R dot A whole square into R cross A. Again apply, because A is a constant vector, so d upon dt will become 0. So what we have? We have first term is as it is. no change in the first term, divided by A, cross product with A divided by R dot A. In the second term, what will happen? In second term, first term will numerator, first term will vanishes. Only left behind the second term, dr upon dt dot with A divided by R dot A whole square into vector R cross A. What is to prove? I think this is to prove for the second part. No, only to differentiate the given function. Only to differentiate the given function with respect to t. I think no further calculation is to be required. That is the result. This will be the result. That is dp upon dt. dp upon dt in the first part. Come to the second part. In second part, again consider the complete whole vector as a p, that is equal to be vector r plus vector a divided by r square plus a square. Be careful about the derivatives. Here the vector r square is what, that is just the magnitude whole square, is a scalar quantity, is a scalar function of t. Similarly, a square is also the is a constant, is a constant function that is independent of t, that is independent of t, independent of t. Therefore, what will happen? Therefore, whatever is the denominator, that is r square plus a square, is a scalar quantity, is a scalar quantity, or you can say scalar function of t. Also, what will happen for the considering the derivative of this r square, that is equal to be derivative of, because this r square is a dot product of r itself, that apply the general rule r dot dr upon dt plus dr upon dt dot with r, because dot product is a commutative, so it will become 2 times of vector r dot with dr upon dt. Therefore, what will happen when we consider the derivative of whole part, that is dp upon dt, will become, again apply the general rule, that is 1 upon r square plus a square, as it is derivative of the second part, which is equal to be vector r plus vector a, plus derivative of this first part, that is equal to 1 upon vector r square plus vector a square into vector r plus a. Just try to simplify it. First part is simply derivative, vector r square plus a square, it will become dr upon dt plus dA upon dt. The second term will be vanishes because vector a is a constant. What will be in second term? As we apply earlier, the derivative of this will becomes the derivative of this r square plus a square divided by r square plus a square whole square. Again apply the rule which we have already mentioned in this one, this rule. This rule will be applicable here also, that is derivative of 1 upon f of t, that is minus 1 upon f of t whole square into derivative of f of t. That is chain rule is to be applied here also into vector r plus vector a. Just simplify it. In the first term, the d upon dt will become 0 because vector a is a constant. Only left behind we have this term. In second also, again we have already considered derivative of r square. We have considered derivative of a square because it is a constant vector. This will become 0. So derivative of r square we have already considered 2r dot dr upon dt. That will be applicable here. So what we'll get? We get dr upon dt divided by r square plus a square minus, it is equal to be 2r dot dr upon dt divided by r square plus a square whole square into r plus a. This will be the derivative of the complete part, which is to be required just to differentiate the given function. Be careful about these parts. Similarly, you can consider the more example of the different type, that is find the unit vector, find the unit vector, unit tangent vector at any point on the curve x is equal to be t square. We have given the parametric equation, y is equal to be 4t minus 5 and z is equal to be 2t square minus 6t. This will be the parametric equation of the given curve, where t is any vector variable. Also determine, first find the unit tangent vector at any point of this curve, and also determine the unit tangent vector at a particular point, vector at the point t is equal to be 2. First we have to determine the unit tangent vector at general point, then find that vector at a particular point. We have already defined what will be the unit tangent vector, that is in the physical significance or geometrical significance of the dr upon dt. Dr upon dt, physical significance, and the geometrical significance of in the terms of dr upon dt at that time we have already discussed. So that is to be determined if r vector r is the position vector of any point generally it is in 3-dimensional x, y, z on the given curve, then the vector r will become xi plus yj zk. This implies vector r is equal to be, after replacing the values of x, y and z, we will get this vector r is equal to be t square plus 2 into I, 4t minus 5 into j, plus 2t square minus 6t into k. This will be the vector r. As we have already discussed, the vector dr upon dt is along the tangent at the general point to the given curve So what will be the tangent? The vector along the tangent will becomes dr upon dt is equal to be derivative with respect to t, that is t square plus 2, that is 2t into I. Then 4t minus 5, derivative will become 4j, 2t square minus 6t, that is 4t minus 6k. This will be the vector along the tangent. And as we already aware about how to find the unit vector in the direction of some vector, that vector itself divided by its magnitude, that is the unit vector in the direction of some vector. So for that part, we have to find the magnitude of this vector, and square root of 2t whole square plus 4 whole square plus 4t minus 6 whole square under the root, that is equal to be 2t whole square and 4t combined, that is 4t square 16. Apply the a minus b whole square, 16t square plus 36 minus 4 to ja 8 6 ja 48t under the root of this part, that is equal to be 20t square minus 48t plus 52. Consider 4 as a common from the each term. That 4 comes out under the root. That will become twice of under the root of 5t square minus 12t plus 30. This will becomes the magnitude of this dr upon dt. Magnitude of this dr upon dt. Now come to the part of the unit vector. As we know, unit vector in the direction of vector A is vector A divided by its magnitude. Therefore, our aim is to determine the unit tangent vector at any point. This is the tangent vector. It means unit vector in this direction is to be determined. It means only to divide this dr upon dt with its magnitude, that will be the unit tangent vector in general. Therefore, the unit tangent vector, it represents as a t cap, that is equal to be dr upon dt divided by magnitude of dr upon dt. dr upon dt divided by magnitude of dr upon dt, that is equal to, what is dr upon dt? dr upon dt is ti plus 2j plus 2t minus 3k divided by, that 2 will be cancelled with the common consider as a 2 from the dr upon dt. So only left behind the square root of 5t square minus 12t plus 13. Because in this one we have 2 consider as a common, in this also we consider 2 as a common, that will be cancelled when these two are to be divided. So we will get the unit tangent vector in the direction at a particular in general point at any point. Now finally we would like to determine the unit tangent vector at t is equal to be 2. Therefore, the unit tangent vector at the point t is equal to be 2 is replace t with 2, that is 2i plus 2j, 2 2 ja 4 minus 3, that is k. This is in numerator. In denominator, square root of t square, that is 4, 4 into 5 20, minus 12 into 2 24, plus 13, that is equal to be 2i plus 2j plus k divided by, that is it will become 20 plus 13, 33 minus 24, 9, square root of 9, that is 3. So our unit tangent vector at the particular point will become 1 by 3 2i plus 2j plus k. This completes the question. Now consider one more example, that is the angle between the two tangents is to be determined. Angles between the two tangents is to be determined, and finally you can determine the velocity and acceleration. Find the angle between the tangents to the curve vector r is equal to be t square I 2tj minus t cube k at the points t is equal to be plus minus 1. Find the angle between the two tangents at these 2 points. At one point is t is equal to be 1, another point is t is equal to be minus 1. Our aim is to determine the angle between these 2 points. Now solution is dr upon dt. First point, the dr upon dt, that is the tangent line. Dr upon dt will become 2t I plus 2j minus 3t square k is a vector along the tangent at any point t. Now consider, now let t1 and t2 be the vectors along the tangents at t is equal to be 1 and t is equal to be minus 1 respectively. Therefore, what will we have? T1 will become, replacing t is equal to be 1. You will get the vector T1, that is 2i plus 2j minus 3k. Vector T1 will become 2i 2j minus 3k, and vector T2, after replacing t is equal to be minus 1, that is minus 2i plus 2j minus 3k, minus 2i plus 2j minus 3k. These two vectors, where angle between these two vectors are to be determined. Our aim is to determine the angle between the T1 and T2. For that part, let theta be the angle between these two. Theta be the angle between T1 and T2. And then, using the rule of the dot product in the cos theta is equal to be dot product of two vectors divided by their product of their magnitude. That formula will be applicable here. T1 dot with T2 divided by their product of their magnitudes. Product of their magnitudes. This is the formula which you have already aware about in the vector calculus in the class 11 or 12. That is dot product of two vectors in component form, just product of their components, I with I, j with j, k with k. That is 2 into minus 2 plus 2 into 2 minus 3 into minus 3. This is the dot product divided by their magnitude. That is under the root of 2 whole square 4 plus 2 whole square 4 plus minus 3 whole square, that is 9. Similarly, in the second part, 2 whole square minus 2 whole square 4, 2 whole square 4 minus 3 whole square, that is 9. In denominator, we got the 9 plus 4, 13 plus 7, 17, and square root 17 into square root 17, that is 17. In numerator, we have 2 to the minus 4, this is plus 9 plus 4, plus 9 plus 4, that is 13, 13 minus 4, that is 9 odds itself. In numerator, we have 9 by, in denominator, we have 17, so which is equal to be cos theta. So angle between these two is theta is equal to be cos inverse 9 by 17. This is the way to determine the angle between the two tangents of the given curve at different points. Finally, we consider an example in which acceleration and velocity is to be determined in the direction of some vector.
Excuse me, sir.
A particle moves. Yeah.
सर कितनी देर की है क्लास और?
अभी ले लेते हैं, कुछ काम है, कोई क्लास है?
नहीं क्लास तो नहीं है बट बच्चे भी कम ही हैं.
कम ही आए हैं तो
हाँ
कम
जी.
ही आए हैं तो वो अपना लॉस बियर करेंगे. तो इंफॉर्मेशन तो सबको थी ना.
यस सर.
इंफॉर्मेशन ना हो तो चलो दूसरी बात है. मैं यही सोचा था ये टॉपिक कंप्लीट हो जाता, क्योंकि इसके 2-3 एग्जांपल और हैं. या लास्ट एग्जांपल यही ले लेते हैं या छोड़ दें, एग्जांपल अपने आप कर लेना. बोलो.
करा दो सर.
करवा दीजिए सर.
करा दें.
यस सर.
ठीक है. Example is a particle moves on the car x is equal to be 2t square, y is equal to be t square minus 4t, z is equal to be 3t minus 5, where t is a time. The and the acceleration at time t is equal to 1 in the direction of I minus 3j plus 2k. This is to be determined. Our aim is to find the velocity component and the acceleration component in the direction of this vector I minus 3j plus 2k. Now come to the part of the solution. First find the velocity as well as acceleration in general at this particular point t is equal to be 1. Then find the component of that velocity and acceleration in this direction. If r, vector r, is the position vector of any point x, y, z on the given curve, then vector r is equal to be xi plus yj plus zk, that is equal to be, replacing the value of x is, that is 2 square I, the value of y is t square minus 4t j, and that value of that one is z is 3t minus 5 into k. This is the vector r. Therefore velocity vector will become the derivative of this r, dr upon dt, that is equal to be 4t I plus 2t minus 4 into j plus 3k. Now this velocity at the particular point, will become, at t is equal to be 1, that will become 4 I at t is equal to be 1, 2 minus 4, that is minus 2j, 3k at t is equal to be 1. Similarly, acceleration also, acceleration will become the d square r upon dt square, that is becomes 4, the derivative of this part again 4 I plus 2j, the third term will become 0 there because of the constant, and it is also equal to be same value because there is no t, 4i plus 2j at t is equal to be 1. Now come to the part, find the velocity vector as well as the acceleration vector in the direction of some vector. For the direction, we determine the unit vector in that direction. Now the unit vector in the direction of I minus 3j plus 2k is I minus 3j plus 2k divided by magnitude of this vector I minus 3j plus 2k, that is equal to be I minus 3j plus 2k. Find the magnitude, that is 1 whole square plus 3 whole minus 3 whole square 9, 2 whole square 4, 9 plus 4 13 plus 1 14, that is square root 14. Let it consider as a unit vector n. Therefore the velocity component or component of velocity in the given direction will become v dot n. That is, what about v? V is 4i minus 2j plus 3k, and n will become I minus 3j plus 2k divided by square root 14. Dot product of these two vectors, simply multiplication of the coefficients of I, coefficient of j, coefficient of k, that will be the dot product, that is 4 into 1 minus 2 into minus 3, 3 into 2 divided by square root 14. In numerator we have the 4 plus 6, 10 plus 6, 16. 16 divided by root 14, so that is to be rationalize square root 14 divided by 14, that will be cancelled, to 8 ja 16, square root 14 divided by 7. This is the velocity component in the given direction. And the component of acceleration and the component of acceleration in the given direction is equal to b vector a dot n. Vector a is 4i plus 2j. Vector n is I minus 3j plus 2k divided by square root 14. Find the dot product of these two. 4 into 1 plus 2 into minus 3. Third one will become 0 divided by square root 14. 4 minus 6, that is minus 2 divided by square root 14. Again rationalize it. 14 into 40 square root 14. 2 7 ja 14, that is minus ka square root 14 divided by 7 will be the acceleration component in the given direction. Acceleration component in the given direction. Okay. This is the way to determining the some particular questions for this part. ठीक है भाई, और ले एग्जांपल क्या कर लोगे?
नहीं सर बस
बहुत हो गया,
कर लेंगे सर।
चलो ठीक है फिर कर लेना भाई। कल कितने बजे क्लास लें? टुमारो एट व्हाट टाइम? अब कंटिन्यू